Let's compose together trigonometric functions with their inverses. So when we do this, we have to be a little bit careful of which order these come in. On each one of these problems that we're going to work in this example, we have the inverse function on the outside. So we're going to use this bottom box here. And then the original function, the original trig function being plugged into the inside. So for these to do some nice canceling out, sine and tangent, when you compose them together, have to be between negative pi over 2 and positive pi over 2. That's where we'd like to be on each one of these. Cosine is kind of the outlier, that it has to be between 0 and pi. So as we work through these, we're going to concentrate on rewriting them so that we land with each of these x's in the right specified range, basically. All right, so like on this first one, we have sine inverse of sine of pi over 3. If we kind of refer back here, is our x in between negative pi over 2 and positive pi over 2? Yeah. A third of a pi is smaller than a half of a pi. So in this case, we're just going to get really nice canceling out. And we can say the answer here is going to be pi over 3. The same thing can kind of be said over here on the right-hand side, that cosine inverse composed with cosine of 2 pi over 3. Now cosine's the weird one. It has to be between 0 and pi. Well, that value being plugged in between 0 and pi. It's only 2/3 of a pi. So we can say, well, you get that really nice canceling out, and that's just going to equal 2 pi over 3. But in this middle one, we don't quite fit into the right range of values here for what's being plugged in. This 2 pi over 3, being that we're dealing with sine inverse composed with sine of x, it has to be between negative pi over 2 and positive pi over 2. So this falls outside of that range. So what I'm going to do in this case, we're going to do a few more in a second, is I'm going to just go ahead and locate where is 2 pi over 3, kind of place this angle. So we know our quadrantal angles, pi over 2 and pi, it's going to fit somewhere into the second quadrant. So 2 pi over 3 kind of wraps around there into the second quadrant. What we can do is we know something about reference angles at this point, or at least we should, that we can draw this reference angle to the x-axis. So I'm going to label that as theta bar, just typical notation here for our reference angle. And then to do that calculation, theta bar is going to be, well, pi minus 2/3 of a pi, 2 pi over 3. So really that's 3 pi over 3 minus 2 pi over 3 is going to be pi over 3 as our reference angle. All right, now why do I care about the reference angle? Well, I can replace what's on the inside here with my reference angle, but as soon as I do so, I have to be a little bit careful about the sign, positive or negative type sign. So I'm just bringing along the sine inverse, the arc sign on the outside. And then on the inside of this function, I want to replace in, instead of 2 pi over 3, I'm going to replace that with pi over 3. So I'm plugging in this reference angle that we just computed down here. But as soon as I plug in a reference angle, this is where I want to double check and be really, really sure about, should this be positive or negative? So I like using the phrase, I always learned it as all students take calculus. So 2 pi over 3 was in the second quadrant. Sine is positive in the second quadrant. So I could put a plus sign out in front here, or I don't really need to include a plus sign if I don't want to. All right, if that had happened to land in either the third or fourth quadrant, I would be doubly sure to make sure I include a negative out in front. Okay, so sine inverse of sine of pi over 3, sine inverse of sine of x up here, that pi over 3 fits in the correct range here between negative pi over 2 and positive pi over 2. So we're going to get that really nice canceling out here. That's just going to equal pi over 3 is our solution for this one. All right, let's take a look down here at the bottom. We have cosine inverse of cosine of negative pi over 3. Now, there are a couple different ways to do this. We could do that reference angle thing again. That would be perfectly fine here. Or if you're comfortable with your even odd identities, we're plugging in a negative angle in here to cosine. You could say to yourself, well, we have some even odd identities. Cosine's an even function. We can just drop the negative. But for our purposes, what I'm going to do first is just go through what I was doing with the reference angle there. All right, so if you're rotating in a negative direction, that's going in the clockwise direction, all right? And we can say we rotated negative pi over 3. down this direction. That lands in the fourth quadrant. We can also go ahead and compute the reference angle in this case is going to be that exact same angle, but we usually say that our reference angle is going to be a positive version of that. So our reference angle is going to be positive pi over 3. So here, as we want to plug that in, we have cosine inverse of cosine of pi over 3. I'm plugging in that reference angle. But here's where I want to double check and think to myself, all students take calculus. As I plug in the reference angle, our initial angle, the negative pi over 3, was in the fourth quadrant. Well, cosine was going to be positive in the fourth quadrant, so I could include a positive out in front here if I wanted to, but I don't really need to. All right, so we're looking at cosine inverse of cosine of pi over 3, just referring back to what we have here at the top, cosine inverse of cosine of x. Well, it has to be between 0 and pi. Sure enough, pi over 3 is in that correct range. So our solution here is just going to be pi over 3. All right, taking a look at two more here, these involving tangents. In this first one, we have tangent inverse of tangent of pi over 8. Just kind of referring back up here to our box, tangent inverse of tangent of x. All right, has to be between negative pi over 2 and positive pi over 2. Sure enough, this one is pi over 8 fits in that correct range. So that's going to be our solution. No additional work really needed in that one. But this last one's a little bit different, that we have tangent inverse of tangent of 11 pi over 9. Now 11 pi over 9, that's an improper fraction. It doesn't fit in this correct range. So I'm going to kind of do that same thing that I just did on these previous ones, but just kind of sketch it in here. Think reference angles. So like I said, improper fraction, it's going to be bigger than 1 pi, but it's going to be smaller than 1.5 pi's as this one works out. So this is going to land in the third quadrant. If I kind of draw in 11 pi over 9. And computing this reference angle, draw it to the x-axis. That reference angle is going to be computed as 11 pi over 9 minus pi, right? The smaller of these two sides is just going around pi. So really that's 11 pi over 9 minus 9 pi over 9, which is equal to 2 pi over 9. So what I'd like to do with my reference angle is go ahead and plug this in. So I'm looking at tangent inverse of tangent of 2 pi over 9. But now here's, remember, where we need to be very, very careful. All students take calculus. Our initial angle, the 11 pi over 9, landed us in the third quadrant. Tangent's going to be positive in the third quadrant. So as I plug in this reference angle, I have to double check that and make sure that it's going to be positive here. Sure enough, this one is. So tangent inverse of tangent of 2 pi over 9 is just going to be 2 pi over 9. All right, hope this helps out. I really would encourage you, have this box kind of memorized on which values are acceptable. That sine and tangent are between the fourth and the first quadrant, whereas cosine is first and second quadrants. All right, good luck. Hope this helps.